Welcome! In this particular video, we'll be solving trigonometric equations involving tangent part 3. Let's take a look at our first example. Example 1. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. Here our equation is 1 plus tangent of theta plus pi over 3 is equal to 3 plus a square root of 3 over 3. So our first step is to isolate the tangent. To do so, let's subtract 1 from both sides of the equation. This will give us tangent of theta plus pi over 3 is equal to 3 plus the square root of 3, all divided by 3 minus 1. Now, let's find the common denominator here, which happens to be 3. So let's multiply this 1 by 3 over 3. Thus, we can rewrite the equation as follows. Tangent of theta plus pi over 3 is equal to 3 plus the square root of 3 over 3 minus 3 over 3. Now, once again, rewriting this equation, we get that tangent of theta plus pi over 3 is equal to 3 plus the square root of 3 minus 3 all over 3. And notice that this 3 and negative 3 cancels out, so we get that tangent of theta plus pi over 3 is equal to the square root of 3 over 3. Now, at this point, we're going to introduce a new variable. So let alpha be equal to theta plus pi over 3. That way, we can rewrite this equation as follows. We can say that this is simply tangent of alpha is equal to square root of 3 over 3. Now, we're looking for any alpha such that its tangent will give you square root of 3 over 3. Now, keep in mind that the period of tangent is equal to pi. So, since the period of tangent of theta is equal to pi, what we're going to do is find any angles between 0 and pi that will satisfy this. So, going back to your table, we're going to find any angles whose tangent gives you a square root of 3 over 3. And those angles happen to be between 0 and pi. So any angle between 0 and pi that will give us an output of square root of 3 over 3. Well, here it is. The angle of interest is pi over 6. So here we get that alpha is equal to pi over 6. Now, using the fact that alpha is equal to pi over 6, let's solve for theta. Now, recall the actual definition of alpha. Alpha was defined to be theta plus pi over 3. So, we're going to say the following. Instead of alpha, we're going to write theta plus pi over 3, and that is equal to pi over 6. So, let's solve for theta. To do so, let's subtract pi over 3 from both sides. Now, here we get that theta is equal to pi over 6 minus pi over 3. Now let's find the common denominator, which happens to be 6. So this is now theta equals pi over 6 minus pi over 3 times 2 over 2. So we can get the common denominator, and this is pi over 6 minus 2 pi over 6, which happens to be negative pi over 6. However, this angle is not on the given restrictions for theta. Recall that theta needs to be greater than or equal to 0 and less than 2 pi. So what we're going to do is the following. We're going to use the fact that the period of tangent of theta is equal to pi, and we're going to add that period to this angle to generate the next angle that will be a solution for this. So we have theta is equal to negative pi over 6 plus the period of pi, which can be rewritten as pi times 6 over 6 to get the same denominator, and that gives you negative pi over 6 plus 6 pi over 6, and that is equal to 5 pi over 6. Now this angle is actually between 0 and 2 pi, so this is one of our solutions. Now, to get another solution, what we can do is to add the period to this previously found angle. So we say, okay, the next theta is equal to 5 pi over 6 plus the period of pi. And pi can be rewritten as pi times 6 over 6, so we can get the same denominator here, which happens to be 5 pi over 6 plus 6 pi over 6. Now 5 pi over 6 plus 6 pi over 6 gives you 11 pi over 6. And again, this is also between 0 and 2 pi. So that's our solution. If we were to add another period of pi, notice that you're really going to be adding 6 pi over 6 to this. That will give you 17 pi over 6, which is far beyond the 2 pi, which in terms of 6's becomes 2 pi times 6 over 6, which is 12 pi over 6. So we're going to stop here in terms of the solutions, and we can say that the solution for this, or the solutions for this equation, happen to be theta equal to 5 pi over 6 and 11 pi over 6. Now let's see another example. Example 2. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. So we have 2 is equal to 1 minus tangent of the opposite of theta plus 5 pi over 4. Once again, the first thing we want to do is to isolate the tangent. To do so, let's subtract 1 from both sides here. So we get 2 minus 1 is equal to negative, or the opposite of tangent of the opposite of theta plus 5 pi over 4. Now here, let's isolate the tangent. Once again, to do so, let's divide by negative 1 in this case. So we have 1 divided by negative 1 is negative 1, and that is equal to tangent of the opposite of theta plus 5 pi over 4. Now, this function has a period of pi, because we take pi divided by the absolute value of this coefficient, which happens to be the absolute value of negative 1, which is 1. So we have pi divided by 1, it's still pi. So at this level, we're going to introduce a new variable and use the fact that the period will be pi as well. So let alpha be equal to the opposite of theta plus 5 pi over 4. Therefore, we have this particular equation. Negative 1 is equal to tangent of alpha. Now, we're looking for any alpha angles such that their tangent will give you negative 1. Now, keep in mind that this alpha will be between 0 and pi because of the period of tangent. So let's go to any values for the angles between 0 and pi that will give us a value of negative 1. Well, here it is. The alpha value here will be 3 pi over 4. So we can say, okay, alpha will be 3 pi over 4. Now, using that value for alpha, let's solve for theta. So using alpha equals 3 pi over 4, solve for theta. Okay, so we have that alpha was simply the opposite of theta plus 5 pi over 4 is equal to 3 pi over 4. Now, let's subtract the 5 pi over 4 from both sides. So we end up with the opposite of theta is equal to 3 pi over 4 minus 5 pi over 4. So we get that the opposite of theta is equal to negative 2 pi over 4, which simplifies really to negative pi over 2 after you divide both numerator and denominator by 2. Okay, so we have the opposite of theta is equal to the opposite of pi over 2. Now, by dividing or multiplying by negative 2 on both sides of the equation, we get that theta is equal to pi over 2. Now, this is an angle between 0 and 2 pi, so that satisfies the condition. That's one of our solutions. To generate the next angle, we say, okay, the next theta is going to be equal to pi over 2 plus the period. The period for this function we said previously was pi. So let me change that pi into pi times 2 over 2 to get the same denominator. So we end up with pi over 2 plus 2 pi over 2, which gives you 3 pi over 2. And that's another angle that is between 0 and 2 pi. Now, if we were to add another period of pi, you're going to get 5 pi over 2, which is beyond the 2 pi restriction here. So we can say at this moment that our solutions are pi over 2 and 3 pi over 2. And that concludes this video on solving trigonometric equations using tangent, part 3. Thank you for watching and have a wonderful day.